Hello YouTube. So today let's discuss a very important aspect of cybersecurity, which is privilege escalation. In my lesson today, or in this video, I'm going to be walking you through Windows privilege escalation and Linux privilege escalation. As you can see here, I have two command prompts. I have the one related to Windows, and I have the one related to Linux. All right. So, so basically here, the importance of privilege escalation in the world of cybersecurity, guys. Uh, Whether you are doing practice boxes or if you are providing penetration testing service to your clients, if you're lucky, when you first gain access to your client's machine as a limited user, um, it is not enough that you gain that access or limited foothold on the system. You need to uh, find a way not to prove that the client is wrong, but you need to understand that limited user is not enough on any system. You need to escalate your privileges. You need to work your way up in the ladder. So that's the purpose of privilege escalation. All right. So I have two command prompts here. All right. So we're gonna explain both in Windows and Linux. So basically here, let's start with Windows. Okay, so the first thing you need to know about, okay, so the concepts are the same in Linux and Windows, all right? So every step we do here, every concept we explain, it holds true for Linux and Windows, all right? There is no difference. The difference is in the details. So now the first thing you need to understand or to know about any system is the current user that you have, assuming that you have gained access to the system either via either in Linux or in Windows. You need to understand who you are. What is the user that's assigned to you? All right. So we can do that on Windows by typing who am I. So basically, it's saying gives me the username I have, and of course on Linux I can do the same. So it gives me the user name of my account or the current account. All right. Now, if I want to have more information about that user, which is Mu'tasim, how can we do that on Windows? We can type net user Mu'tasim, and this gives me more detailed view of what this user is all about. What are the attributes of the user? As you can see, the username, the full name, country information, account active, when it expires, information about the passwords. Of course, it doesn't display the password, but the password operation and other useful information that may come in handy later down the road. On Linux, guys, if I want to have more detailed information about the current user, I can type ID, and here it gives me more detailed info about the current user. You see the UID, the group, the GID, and the group the user belongs to, and other useful info about that user. These info are very important, although they are not directly related to privilege escalation, but you need to understand who you are on the system. Now, assuming that you want, okay, you know who you are right now. You want to know who are the users on the system. I want to understand who are the users that I'm gonna exploit, right? So on Windows, I can type net user, and it gives me here, as you can see, the users on that system. So I have here the default account and the guest account and administrator. On Linux, the only way to know how many users or who are the users on the system is to use or display the content of the password file. Now, if the file is secured enough, you cannot gain access to that file. Sorry. So basically, because right now I'm a user on the system and I have privilege to view the content, I can see the users. So, but assuming that your user that you are assigned to when you gained access to the system may not be able to view the content of the password file. So you may not be able to know who are the users on the system initially in your scan or in your testing. So assuming the password file is misconfigured or your user has privileges to view the content of the file, you will be able to see the users on that system. So as you can see here, it's me only. The other users are, of course, you have the web server user and root. All right, now, next thing, guys, you need to understand or need to know when we enumerate for the privilege escalation is the host name. So basically, the host name, we can use the host name on Windows by typing the same command, Linux and Windows. So host name, that's my host name. I can change it, it's changeable. The same for Linux, it's Kernel. Now, so far, you have gained a basic idea about the user you are assigned to, and if you are looking on Linux, you have gained info about the users running on the system or existed on the system. So now the next step, guys, is to need to know what is the operating system and architecture. Why it's important to understand what is the operating system, the version, and the architecture. Why? Because as you know, guys, at some point during the privileged escalation process, we may need to rely on kernel exploits that specifically exploit vulnerabilities in the core of the target's operating system. So basically, kernel exploits are kind of exploits that work on exploiting operating systems with specific versions. What does that mean? It means that these types of exploits are built for a very specific type of target, very specific very specific version, specified, of course, by particular operating system and version combination. So since attacking a target with mismatched, let's say mismatched kernel exploit. So let's say here the version. Let's find the version number of the system. So your name on Linux. So that's the version, right? So this version, if it is vulnerable, it's going to have a matched exploit that only works on this version, right? So that's why the version of the operating system is very important, and don't try to gather many exploits on the internet and try it on specific version of your system. Why? Because if you are doing that in corporate settings and out of the blue you may end up missing your client machine. Because sometimes trying different exploits or mismatched exploits or a version that is not vulnerable to these exploits, this may lead to crash on the system of your client, of course, and probably you will lose the client. So basically, be careful. That's why knowing the version of the system, the number, and the architecture is very important, so you can use an exploit, or hopefully you can develop an exploit that's specifically crafted for this version. So on Linux, we can know the version by using uname -a, or we can use the cat etc issue. Okay, let's use the release cat etc. All right. So I have all the information about the system, but I prefer to use new name -a. It's very clear. The output is very clear. I don't need to read many lines. Just it pops the version right away. I have the version now. I can go online and look for an exploit. Now on Windows, how can we define, or how can we know the version of the operating system? So basically, you can use system info command. System info gives you all the info about the operating system. Let's find out. Okay, so go down. So basically, the OS version is 10.0. Here you go, guys. Just search for an exploit for my system and kick my ass. So the OS manufacturer, all the info you need, but most specifically, what you need, guys, for the privilege escalation is the version and the name. All right. Now, after this step, you may want to use an automated scanner to find you an exploit online, or you may go ahead if you have time, if you don't have many clients waiting for your penetration testing reports, you can go ahead and find an exploit online by yourself without the use of automated tools. Okay. Now we have determined the users running on the system, the operating system, the architecture. We have gained some basic knowledge about the system. Now, if you have found an exploit for the version of the OS you are enumerating, full stop, period, you're testing, you're gonna hand the report to the client. Hey, I'm gonna say, hey, whatsoever, I have gained access to your system, and your system is vulnerable to, or the patch or the OS system is vulnerable to these, and could be exploited by this exploit. Here's my recommendation: patch your, tell your system administrators to patch the system. If not, if the system is patched, we can step our game up and go to the next level, which is enumerating the running processes and services. So basically here, guys, in order, we need to understand that enumerating processes and services only to serve us one purpose. We need to find a process or service or a process that's attached to service, or a service that's attached to a process, which has weak file permissions or misconfigured file permissions, and the process is run under a privileged user. If I have a process that is connected to files under weak permissions, but the process is run under a non-privileged user, right? So I have no use for this process. And vice versa, if the process is run by privileged user, but it is not misconfigured, all file permissions are okay, I have nothing to do with it. So how can we enumerate the running processes on Windows? So basically, we need to understand that we need to view the processes and we need to view the attached services to it. So on Windows, I can do that with task list /svc. Okay, so we go up. As you can see here, I have the process name, the PID, and the services. So these are the running processes on my system, and these are the associated services. So now, over here, I can select one process and gain more information about the underlying configuration of this process. Of course, there are many tools on sysinternals that enable you to, gain more insights on each process. Okay. But you need to keep in mind that the output doesn't list the processes, In Windows, the case is different. So on Windows, you need to understand these processes are not run by privileged users. Why? Because on Windows, you need to know that the output of this output over here, it doesn't list the processes run by privileged users. So Windows-based systems, we will need higher privileges than the users we are assigned to, to gather more information about what are the processes that are run by privileged and non-privileged users, which makes the task of elevating your privilege on Windows client relying on exploiting misconfigured processes very difficult. Why? Because these services are run under non-privileged users. So what I have here only insights, what's running right now on the system, but I cannot know among which of these processes the privileged ones, right? On Linux, it is not like this. In Linux, it is easier to know the privileged and non-privileged users processes. So we use PS, and the switches is very confusing. I know that. I'm going to explain switch by switch. So basically, we use A and X. So Y and X, guys, I need to list all the active processes with or without TTY, right? And I'm going to use U flag to make the output readable. Let's enter. All right, so as you can see, the difference between the output in Linux and Windows is that I know which process is run by root and which process is run by my limited account. That's the difference. That's what makes excluding misconfigured processes on Linux easier than Windows. So Windows beats Linux in this. We got to admit this. Okay. So as I told you guys, processes are very important. You need to pick up on the processes that are run by root, right? Pick up on these processes, enumerate them more, and find if these processes, okay, are connected to binary or file, to binary file. The binary file of this process is run under weak permissions. So if it is run under weak permissions and assigned under root, you've got your jackpot. All you have to do is to modify the binary to work on your favor. Okay, now the next phase of privilege escalation, guys, is enumerating network information. So network information can help you determine if the compromised target is connected to multiple networks and therefore could be used as a pivot. So basically, imagine your client has kind of Active Directory domain structure, or let's say domain controller, and you compromised one of the endpoints connected to that domain controller. Now, obviously and definitely, the network information is very useful to you guys. Why? Because you can pivot and jump from one endpoint to another endpoint inside the domain controller, all the way till you compromise the admin domain controller. That's why network information are very useful, guys. Now, also, the port bindings are very important. We can also investigate port bindings to see if a running service is only available on a loopback address. What I mean by that is, imagine investigating a privileged program or service listening on a loopback interface. This could expand your attack surface and increase your probability of privileged escalation attack. So basically, how can we gain network information on Windows? We can use ipconfig/all. Here you need to inspect all the adapters on the system. So basically here I have, how many adapters I have? Ethernet 4, which is Fortinet virtual Ethernet adapter because I have Fortinet VPN. As you can see, if you see many Ethernet adapters, it means that there are kind of antivirus softwares, VPN softwares running on the system. As you can see, VPN, 2 VPNs. Here is the also Fortinet SSL VPN virtual adapter, and the rest are for Microsoft, and of course, VMware and Realtek, the Wi-Fi adapter. Now, as I told you guys, these info are very useful if you are enumerating a client within a domain controller. Also, it's very important and useful for you guys to have insights on the routing table. So route print. The routing table, guys, displays the network path taken by your machine whenever it's as you can see, the network path the machine takes whenever it tries to reach a specific destination. So, and what is the gateway used to accomplish this task? So basically here, the network destination here, and the gateway used for that, and the interface used to connect to that gateway. And lastly, of course, guys, after having information about the routing table and the virtual adapters, we need to know the active connections of the current machine, and that's when the picture is completed about whether we can pivot our escalation from one machine to another. So Windows, we can use netstat, ANO, netstat. So it displays all the active network connections, the listening ones and the established ones, and the process PID used to establish that connection. These information are very important, guys, of course, to forensic investigators, but also for penetration testers. Why? As I told you guys, if this machine is part of domain controller, you would be able to understand what are the connections originating from this machine and what is the process. And that's how you establish your pivot point or pivot baseline. So not only did netstat provide us with a list of all the listening ports on the machine, it also included information about established connections here. This is established that could reveal other users connected to this machine that we may want to target later. Oops, what happened? So also, guys, people who launched these DOS attacks, when they compromise a target machine, they view the active network connections. Why? Because they want to piggyback on the current machine on the machine that's connected to the compromised one. So they can expand and build on, or let's not say build on, they can expand their attacking surface from this machine to all the machines that are connected or have established connection to this compromised machine. Now, the network information on Linux. All you know, guys, ifconfig, or you can type IPA to have info about the network interfaces. Now, the routing table, we can use route.ctl, or router, sorry. And for the running processes, we can use ss. Oops, no. ANP, I want to list the processes, so I put P. So it's the same concept, guys. Established. Oh my God, how many connections I have established to my machine? I think I am kind of zombie here, guys. I don't know, my machine might be compromised. Look how many established connections. Okay. Nevertheless. Okay, now we have enumerated the operating system, the version of the operating system, the running processes, services, the network connections, and the current user. And by far, And by far, most of the time, your job of escalating your privilege will have been accomplished, since most of the vulnerabilities are or most of the exploits work on kind of not bashed operating system or misconfigured process. But sometimes you need to enumerate more because the operating system might be up to date. There might be patch management process for your clients. They do updates on a regular basis every month, one time, two times. The processes might be in good shape. The victim is not part of domain controller, and there is no many established connections that could be used as a piggyback. So the next step, guys, we need to find the firewall rules. Okay, the firewall rules, enumerating firewall rules. I don't know what to say about this, but enumerating firewall rules is kind of helpful, guys, when you have determined that this machine is a pivot point. So assuming that this machine is not a pivot point, enumerating firewall rules won't help us unless we are planning to do port forwarding to our attacking machine. So, but nevertheless, let me explain the firewall rules, guys. So generally speaking, firewall state profile rules are only of interest during the remote exploitation phase of an assessment. However, as you know, guys, this information can be useful during privileged escalation if it is a pivot point. For example, if a network service is not remotely accessible because it is blocked by the firewall, it is generally accessible locally via the loopback interface. So if you can interact somehow with these services locally, we may be able to exploit them to escalate our privileges on the local system. So in addition, also we can gather info about inbound and outbound port filtering during this phase to facilitate port forwarding and tunneling when it's time to pivot to the internal network. So on Windows, firewall rules are enumerated. Oh, okay. We're using netsh and the switch advanced firewall show current profile. So it shows me that the firewall is on, and the policy is block inbound, allow outbound, basic default policy. So I want to expand on this. Since the firewall is on, I want to see more information about the rules. So netsh advanced firewall show root current profile, put rule name equal all. Okay, I think here we miss switch. Okay. Stop. So here are the firewall rules. Good luck inspecting them. Let's take an example. I don't know. So this one, rule name is for Microsoft Edge, enabled direction in, and the action is allow. Inbound. Yeah, since the browsing is two-way communication. What is this? Microsoft Windows Content Delivery Manager. I have no idea what is this. So direction is out and the action is allowed. So basically this policy allows this app, don't know what it is, to establish internet connection outside or outbound, connections originating from my machine, not to my machine. Okay, that's for Windows. Now for Linux, the case is different. For Linux, if you want to inspect firewall rules, you need to be privileged user account. You do that using IP tables. So since we are talking about privileged escalation, We are assuming that you are a non-privileged user, so you cannot inspect firewall rules on Linux. Now, the next thing is enumerating scheduled tasks. So basically, guys, systems that act as servers, for example, often periodically execute various automated scheduled tasks. The scheduling systems on these servers often have somewhat confusing syntax, which is used to execute user-created executable files or scripts. Now, when these systems are misconfigured, or the user-created files are left with insecure permissions, we can modify these files that are linked to scheduled tasks, so it will execute our code. Now, that's how you enumerate, that's how you manipulate scheduled tasks. You need to look for a task that is misconfigured with weak file permissions and is run under high privilege level. So we can do that on Windows, let's say, enumerate scheduled task with what was it? Okay, tasks. Okay, this alone will give you so much information. You need to use query, displays the tasks, and the output needs to be friendly. So we use fo list and variables. So these are the scheduled tasks. So this one, for example, it says task name is kind of Xbox, right? And the next runtime is unknown. What's important is the next runtime, the task name, and the task to run, guys. This is the file that you need to manipulate and modify if it has big permissions. The author is Microsoft. Run as user. Here it says system. So more than likely, guys, if this process of this binary has weak file permissions, if I modify the file to execute my code, I will gain system-wide access. Why? Because it's running under system and it has weak file permissions, assuming, hypothetically, that it doesn't have. Now, let's see how can we do that with Linux. With Linux, viewing scheduled task is accomplished by viewing the content of the cron tab. So ls, lah, etc, cron. Guys, cron is divided and splitted by daily, hourly, whatsoever. But you need to find all of them. So here I can see the daily ones, hourly ones, monthly ones, weekly ones. What's important for me here is the ones that are running under root. So technically everything is running under root here. I want to find the non-secure ones, the ones that I can modify as a user. So basically for me, I have no chance. Look, no chance of modifying everything, nothing. So these here, for everyone, the permission is read. Here I can only execute, only read, execute, read. There is no room for messing up things here. So that's how we inspect the cron tab, the scheduled task on Linux. Also, guys, it's worth noting that the system administrators often add their own scheduled tasks in the etc cron tab file. So it's worth noting that there's another place to look for. Cat etc cron tab. So the output here would sync. I have this one. No, nothing actually. So nothing is running as a cron job. I mean, configured by me here. I have not configured anything to run as a cron, either hourly, daily, monthly, whatsoever. If there is something that's running, there is something that has been configured by an administrator to run on a regular basis, you will find it either in cron star, the cron here, or view cron tab. You need to look for both. All right. Now, the next step, guys, is enumerating the installed applications and examining the patch levels of the client. Why I'm saying this? Because at some point, we may need to leverage an exploit to escalate our privileges, like we did for operating systems. If so, our search for a working exploit begins with the enumeration of all installed applications, noting the version of each. So the version is the most paramount aspect of enumerating this kind of stuff. But manually searching for every app is time-consuming, tedious, and exhausting. So in Windows, there is a tool called Windows Management Instrumentation. You can use that tool to enumerate all the applications that have been installed on the system using the Windows installer. Right? So you need to write underline this many times. Only the applications that are installed using Windows installer can be enumerated with Windows Instrumentation Management. How? I use the I name it W mic, not to forget it, and I use product to indicate that I am enumerating the applications, and get is stands for or used to retrieve a list of the properties of a specific application. The properties I'm interested in are name of the app, the version, and lastly, the vendor. What? Guide? So information about uninstalled applications could be useful as we look for privilege escalation attacks, as you know. But okay, I got this? No. Now on Linux, while this is running, on Linux I can retrieve, it's different from distribution to distribution basically. So as you know, enumerating the applications on Linux is done by using package managers. So on Linux, there's Debian, there's Red Hat, whatsoever. So on Debian, the package manager is the package, while on Red Hat is RPM. So the syntax is different. But you get the idea, you need to enumerate the packages. So find the command for your system. For me, it is Debian, so I'm going to use the package. I love Linux, way quicker than Windows. Okay, here is the name of the app, the version, architecture, and description. So go ahead, take the name of the app, take the version, and find out if you can. Oh, there is line. Okay, more lines. Tedious. Okay, so that is the process. Let's see Windows, what happens with Windows. All right, finally. So Windows, as you can see, I have the name of the app. Congratulations, you have determined or you have found out what are the apps I am running. Google Ads Editor, the vendor, and the version. So you get the idea. Your job is to find an app with a vulnerable version to exploit in order to escalate your privileges. Okay, now, so far we have gained a massive insight on the system. But assuming that you are, assuming that you have bad luck, and so far you have not found a way to escalate your privileges, your next step is to enumerate the readable or writable files and directories. And most of the time, this is where you arrive to your goal. Because most of the time and most of the cases I have witnessed is people underestimating the power of exploiting weak file permissions. They underestimate how this is dangerous. So I think if you want to save you, of course, guys, do note that the order of the concepts I have laid down today is not mandatory. So you don't need to follow the order I told you guys, right? You only understand the concepts, but you may try the order for the order that suits your preferences, suits your interest. You may study the aspects and find out what is the least time consuming and start with it. So your way is maybe different than my way. For me, this is my way of starting the enumeration. So now let's explore the writable and readable files to find out what is that file that has weak permissions. Okay, on Windows there is a tool called access check. I don't have it. As far as I remember, I installed this, but it seems that, let me go to Google. So access check, yes. From here. So this tool guide is a great tool to find all the files, all the directories, the binaries on the system that are misconfigured. But you need to use that on the command line and define what is the permission you are after. So here it gives you like guide about the use of this. But I don't know why it's not working on my system, but the syntax, if you want to find, let me tell you guys, specifically, we need to enumerate, we need to define a directory that we intend to enumerate, and we need to find the everyone group. Okay, we need to find the files and directories that have everyone group or everyone as a user with right permissions. So basically, my way is access check, and we suppress the error with -u. Let me check. So -u suppress errors. Yes, exactly. And I put W because I am interested in write access permissions, and S to perform recursive search, files, directories, whatsoever. Now, next, I need to define who is the user, or what is the group that I'm interested to find the right permissions that's connected to it. So in my case, it's everyone. And next, I define the path \. Okay, \/ is not working on my. So let's say program files. Okay, but here be sure to replace the / with the back one. Let's make sure that we type the correct one. So recursive with S, U suppress error, and W for the permissions, right permissions. Show only objects that have write access. Yes. And we specified the file or directory and the username. Now, once you hit enter, okay, we'll find all the files or directories, okay, that have write permissions for the group of everyone. All right. Now you can accomplish the same on Linux using the find command, basically. But let's assume that actually using access check requires you to transfer the tool to the system you have access to. Suppose that you cannot download any tool due to network issues, internet connection issues, or permission issues. So in this case, this example is not practical at all. So basically, you need to use the thing that I hate the most is PowerShell. So PowerShell, you can use PowerShell to find out the files and directories that have weak permissions. So the primary cmdlet we are using is get. I have to run PowerShell. Okay, PowerShell. Okay, so the primary cmdlet is get ACL, right? Which retrieves all permissions for a given file or directory. However, sometimes get ACL cannot retrieve the files or cannot do the search recursively. So sometimes we replace get ACL with child items. The directory we are interested in is program files. So this effectively retrieve every single object in our target directory along with all associated access permissions. So next we type, I need to find double quote. Okay. The path is, I'm going to copy the path. I don't want to use this one. Okay. And we use -r for recurse. And after that, we use pipe. Okay, finally. Now I put here get ACL. Let's copy the pipe again. I don't want to look for it 1,000 times. And let me copy the command. Okay. Now here, I have access to string property. The access to string property here with the -match flag narrows down the results to the specific access properties we are looking for. In our case, we are searching for any object that can be modified by members of the everyone group. So access to string saves me time by telling the OS, say, look, I want to look for the files, binaries, directories, okay, that are modifiable, okay, by everyone or by members of the everyone group. Technically, everyone outside the system. Let's see. And you hit enter, you will find out what are the misconfigured files that you can gain access and modify. I don't think we will find something. By the way, I'm now auditing my system. I haven't done that before, but you get the idea. Okay, let's see on Linux. How can we find out the misconfigured files? Okay, it's very easy. You type find, and then you search the whole root directory for writable files. Okay, the type you specify is it's file or directory, right? And you pipe the errors to dev null, of course. So all these files are writable by me. As you can see, I'm going to stop this. Of course, you can use that for files and for directories. Now, the next thing, guys, after most of the time you have by far you must have found something of interest that you can edit, modify, put your netcut listener, and have root access. So on Windows, there is no file or directory that has that is modifiable under any member of the everyone group, which means I'm secure now, right? Okay, the next thing we need to enumerate, guys, is enumerating the device drivers and kernel modules. Why? So as you know, it's another common privilege escalation techniques. Involves exploitation of device drivers and kernel modules. Uh, Basically, drivers and kernel modules are the most difficult to exploit. But in my experience, once you find the version or the driver, or once you find an exploit that is related to that driver, you can apply the same concept when you exploit a vulnerable operating system or a vulnerable application. So on Windows, you can use a PowerShell for that, but on Linux, you can use ls mode to view the drivers and the kernel modules and their versions, right? There's no versions here. So I think we need to use mod info. Yes, mod info. Let's take one. Let's take this one. And then you use mod info. Mod info. And you put the modules you are interested in enumerating. Paste. Okay, let's say button. Boom. Okay, so I got here the version. No, this is the file name. Okay. So here I have version information, as you can see. But there is something not familiar here in this module. Let me use something else. Let's use this one. Okay, mod info. Okay, so this is the version of the driver. And you do the same way when you search or look for the vulnerability, when you do that for the applications, when executing applications or OSs. Now for Windows, again, to enumerate the kernels and kernel modules and drivers, you need to use PowerShell. And for my luck, there is a command for this, but I cannot remember this command actually. You can find it on the internet, guys, enumerating modules, kernel modules, and drivers on Windows using PowerShell. There must be a way for this, but I cannot remember it. Okay, the next thing, guys, is looking for the binaries that have the SUID bit set on Linux or on Windows. Now, I have wondered how we can do that on Windows. How can we find the applications on Windows that are executable and can be run both by normal user, non-privileged one, and privileged one? So it means when you have the SUID bit on a binary app in Linux or Windows, it means that this binary file is run by its owner or under the context of its owner, even if the user that is running the app is not the owner. That's one of the most frequently how can I say it? One of the most frequently used misconfiguration to elevate your privilege on Linux systems and on Windows, of course. Now, Windows, you can do that using the registry key, by the way. So on Windows, okay. So there is a registry key. You can find it in current user or current machine that if it has 1 or if this value is 1, it means that you on Windows, all the applications on Windows can run under the context of a privileged account. This was why. Okay, let's see if it is on machine. Invalid key name. I'm gonna assume that. Okay. So on the first one, there is no app on my system that is running under the context of a privileged account. Every app or every binary is run under the context of the current user. Now on Linux, you can do that by using, of course, also the find command. In the find command, search under the whole root directory for all the binaries that have the SUID bit set. And the type, of course, will be file. The binary file is not a directory, right? So 2, and I piped to there. No. So I have some issues here, I guess. So your job now is to find one of these apps, or to look for an app among these apps, or let's say in Linux language a binary among these binaries, so you can run it and find a way to use it to exploit or elevate your privileges. So here, copy. There is no copy. CSFN password. Most of the time, on every Linux system, there are binaries that have the SUID bit set, and that's okay. Some binaries need that. But you need to look for, depending on the configuration of the system, you need to try and find out which one of these, okay, has weak permissions, so you can modify it, right? So the next condition or the stipulation is you find an app that has the SUID bit set. Great, it can be run and root, but if it is not associated with weak file permissions, then game over. Okay, now most of the time you will not run these phases, or you will not enumerate your system, the client system. Most of the time you will not do that, as it is time consuming and exhausting. If you have time, of course, you can do that, but the manual process of enumerating for privilege escalation opportunities is very helpful, okay, when you are stuck with the automated testing. So there are many tools to use automated privilege escalation, right? But if you didn't find anything using the automated tools, you need to be knowledgeable on the manual techniques. In general, the manual techniques, okay, can be performed all the time, but the only disadvantage is the time and the tedious. It's tedious, It's not if you have like 7 clients and you are doing privilege escalation for 7 clients all the time, the same way, but it's not time effective, right? But for one client, okay, use manual testing if you have time. But my recommendation to use automated testing. There are many scripts and tools to perform automated privilege escalation testing or enumeration, right? Now, if you have not found what you're looking for using automated testing, you can use the manual testing like we outlined in this video to find out, to unleash and unveil what was hidden with the automated testing. Now, if you can't find with automated and you can't find with manual testing, then my recommendation is to, leave your place to someone else. Every system must be vulnerable in some point. I mean, at some point, some system could appear to be not hackable, right? Or doesn't have any loophole or any entry for exploitation. But most of the time, believe me, guys, 80% of the systems are vulnerable. You know, there is some way that you can use to at least do some harm or demonstrate that some harm could be demonstrated or could be uh, performed on the system. Of course, when I'm saying 80% of the system are vulnerable, I'm not saying that all the systems, all of these 80% are vulnerable to privilege escalation and you can root all of them. No. Privilege escalation is a technique to elevate or to make yourself super admin on the system. So you can be limitless, right? But when I'm saying 80% of the system are vulnerable, it could be to privilege escalation attacks, it could be to limited escalation attacks, it could be, the countless ways of exploiting a system. So I hope this lesson was somewhat informative and helpful, and hopefully we see you in the next video.